when we were finding antiderivatives, there's in general there's a whole family of functions that would be an antiderivative for a particular function. So, for example, the integral of k du is k times u plus a constant, or do another example here. Antiderivative of sine of u is minus cosine of u plus a constant. So there's a whole family of functions that have the same derivative. For initial value problems, there's some additional conditions that will help us determine a particular antiderivative. So we'll have, these conditions will enable us to determine a particular value for c for the constant c that fits those conditions, and these are called initial value problems. So in this example, when fuel ran out, the rocket was 32 feet above the ground. So that's one of the initial values, and traveling upward at a velocity of 16 feet per second. So those are two initial values. Meanwhile, gravity is slowing the rocket down at a rate of 32 feet per second. Assuming the effective air resistance on the rocket is small enough to be ignored. We want to compute the velocity of the rocket at the time t seconds after fuel runs out. So we start with the acceleration, so we have constant acceleration. So a of t, the acceleration a of t is equal to 32, and the velocity is going to be the antiderivative of acceleration. So v of t is going to be the antiderivative of the acceleration. So it's the antiderivative of 32 dt, and that's going to be 32t plus a constant. And then, so we want to figure out what value of this constant is going to satisfy the initial condition, which was that the initial velocity was 16 feet per second. So at v of 0 should equal 16. So v of 0 is going to be 32 times 0 plus the constant, and that should equal 16. Well, 32 times 0 is 0, so so that means the constant has to equal 16. So that means, so that was the initial condition. That's why it's called initial value problem. So v of t is going to be 32t plus 16. Actually, no, this should have been negative 32. Gravity pulls down, so usually we want to write the acceleration due to gravity with a minus sign. So it should be minus 32t plus 16. Okay, so part B, we want to compute the height of the rocket at time t seconds after fuel runs out. So again, this is part of our initial conditions. We had initially when the fuel ran out, the rocket was 32 feet. So that was another initial condition that was given that we're going to use for this part. So anyway, the height is going to be the antiderivative of velocity. So it's going to be the antiderivative of minus 32t plus 16 dt. And so we could use the power rule here. So this is t squared over 2, minus 32 t squared over 2 plus 16t plus a constant. 2 into 32 goes 16 times. So this will equal minus 16 t squared plus 16t plus a constant. And the height at time 0 would be h of 0 is this is 0 plus 0 plus a constant, and that was given to be 16. no, 32. So that the initial height was 32. So so that means the constant is equal to 32, and that means that h of t is minus 16t squared plus 16t plus 32. Okay, so that's the height of rocket t seconds after the fuel runs out. Okay, so we can use this to find the maximum height. There's a couple ways we can find the maximum height, but we could the maximum height is going to occur when the velocity is 0, because the this is going to be a parabola. The height of the rocket is you have t to the second power. That indicates it's a parabola, and because the coefficient of t squared is negative, it's going to open downward. So the picture is going to look something like this, and the maximum height. So you have positive velocity initially, and then gravity slows it down, and then eventually it has negative velocity. It comes down to the bottom. So the maximum height is going to be when the velocity is 0. It's going to be at this point here. So we can find the time if we set the velocity equal to 0. So step 1, v of t equals 0. That means that minus 32t plus 16 equals 0. And if we subtract 16 from both sides, we get minus 32t equals minus 16. Divide both sides by minus 32. You get t is equal to 1/2. So the maximum height occurs after 1/2 second, and then you can do h of 1/2. Step 2. Do h of 1/2 minus 16 1/2 squared plus 16 times 1/2 plus 32. 1 squared is 1/4. Fourth of 16 is negative 4. Half of 16 is 8. So we have negative 4 plus 8 plus 32, and that's going to be 36 feet. So the maximum height is 36 feet. The velocity as the rocket hits the ground. Okay, so let's find step 1. Find what the time it hits the ground. When it hits the ground, the height is 0. So step 1, we can solve h of t equals 0. So that means that minus 16 t squared plus 16t plus 32 equals 0. If we divide everything by negative 16, we can make these numbers a little smaller, easier to work with. We'll have t squared minus t minus 2 equals 0. And then we'll see if we can factor that. T times t is t squared. We need two numbers to multiply to negative 2, add up to negative 1. So let's try 1 and negative 2. Getting this thing popping up on my screen here. And you can check with the FOIL method. T times t is t squared. Outer product negative 2t. Inner product 1t. Add those, you get negative 1t. Last times last. 1 times negative 2 is negative 2. So that means that this will be 0 when t is equal to negative 1, or t is equal to 2. So we don't want to go backwards in time. We want to go forward in time. So the time that we're going to use is t equal to 2 seconds. Now this is measured in seconds. Okay, so then want the velocity of the rocket as it hits the ground. That's going to be v of 2. So step 2, v of 2, velocity is minus 32 times 2 plus 16, minus 64 plus 16, be minus 48 feet per second. Okay, so that's an initial value problem. Generally, when you take the antiderivative, you get plus a constant, and in order to find out what the constant is, we put in the initial velocity of 16 feet per second, or down here we're putting in the initial height of 32 feet. Okay, so that gives us a specific antiderivative. Okay. Okay. So here's basically the same problem, but we just changed the numbers a little bit. So in this case, the fuel ran out when the rocket was 112 feet above the ground and traveling upward at a velocity of 96 feet per second. So velocity at time t seconds after the fuel runs out. Okay, so the acceleration is still the same. The acceleration due to gravity, a of t, is negative 32 feet per second, and v of t is going to be an antiderivative of the acceleration. So it's going to be antiderivative of negative 32 dt, negative 32 t plus a constant. And then we want to use the initial condition. We initially had an upward velocity of 96 feet per second. So we're going to solve. So we can call this step 1, step 2. V of 0 is minus 32 times 0 plus a constant, and that was given to be 96 feet per second. So that means that negative 32 times 0 is 0, so that means that the constant is 96, and that means that v of t is negative 32t plus 96. And then the height of the rocket at time t seconds after the fuel runs out, well, the height is going to be the antiderivative of the velocity. So this is going to be the antiderivative of minus 32t plus 96. And we use a power rule. It'll be minus 32 t squared over 2 plus 96t plus a constant. And 2 and 32 goes 16, so it's minus 16t squared plus 96t plus a constant. And we want h of 0. It's going to be 0 plus a constant. And the height at time 0 was 112 feet. This is 112 feet there. That was the initial value. And that means the constant has to be 112. So h of t, so this is step 2, h of t is minus 16t squared plus 96t plus 112. Okay, so okay, so then the maximum height of the rocket. Oh, actually, this should have been yeah, the maximum height of the rocket. That's what we want. So again, the maximum height is going to occur when the velocity is 0. So the graph, this is a parabola opening downwards. The graph looks something like this, and maximum height, velocity is just the slope of the tangent line, and that's going to be 0 at the maximum. So we want to solve step 1, I want to solve v of 0, v of t rather, is equal to 0. That means that minus 32t plus 96 equals 0. Subtract 96 from both sides. Get minus 32t equals minus 96, divided by minus 32. And that gives t is equal to 3 seconds. Okay, so then so then we want the height at time 3 then. So step 2, height h of 3 is going to be minus 16 3 squared plus 96 times 3 plus 112. This would be minus 144. 288 plus 288 plus 112. And this is going to be 256 feet. The velocity of the rocket as it hits the ground. So step 1, it hits the ground when the height is 0. So h of 0 h of t rather. H of t equals 0, so that means that minus 16 t squared plus 96t plus 112 equals 0. I think everything's divisible by negative 16, so let's divide by negative 16 just to make the numbers smaller. And we'll get t squared minus 6t minus 7 equals 0, and we can factor that. T times t is t squared. We need two numbers to multiply negative 7, add up to negative 6, and plus 1 and negative 7. And that means that t equals negative 1 or t equals 7 seconds. We don't want to go backwards in time, so this is going to be our answer here for the time. And then we want v of 7. So step 2, v of 7 is going to be minus 32 times 7 plus 96. So that's going to be going pretty fast. 32 times 7. 32 times 7. 7 times 2 is 14. 3 times 7 is 20. 22. Minus 224 plus 96. 14, 8. 13, 4. That doesn't look right. 14, 8, 11, that's 2. Okay, so it's negative 128 feet per second would be the velocity as the rocket is hitting the ground. Okay, so here's some additional initial value problems. Some of the problems in WebAssign and in the textbook are sort of generic problems without a particular context. I like to at least do some examples that have some context to them. These are just sort of generic functions that don't have a particular context. So, but the principle is the same. We're given some a second derivative here. In the examples that I just went over, we were given velocity. I mean the acceleration. We're given acceleration and two initial conditions. velocity and at time 0 and the height at time 0. But so this is the same principle here. We're given the second derivative is equal to 4. The first derivative at time when x is 0 is negative 3, and the original function when x is 0 is equal to 1. So we can take the antiderivative of f double prime. So f prime of x is going to be the antiderivative of f double prime of x dx. So that's the antiderivative of 4 dx. And that's going to be 4x plus a constant. And then we want to find out what the constant is. So I guess we'll call this step 1. Step 2, you want to solve f prime of 0 is 4 times 0 plus a constant. And that was given to be negative 3. So that means that the constant is negative 3. Therefore, f prime of x is 4x minus 3. And then step 3, we want f of x. Now we have the function itself. F of x is the antiderivative of f prime of x dx. So that's going to be the antiderivative of 4x minus 3 dx. And we can use the power rule here. Add 1 to the exponent, divide by the new exponent. 4x squared over 2 minus 3x plus a constant. 2 into 4 goes 2, so it's 2x squared minus 3x plus a constant. And step 4, we have another initial value here. F of 0 is equal to 1. So f of 0 with this formula is 0 minus 0 plus constant, and that has to equal 1. That means that the constant is 1. So that means that f of x is 2x squared minus 3x plus 1. Okay, so that's sort of a generic, same methods applied to a kind of a generic function without any particular context. Another example here, the same thing. We're given f double prime of x, so f prime of x is going to be the antiderivative of f double prime of x. And that's the antiderivative of 6 dx. And that's equal to 6x plus a constant. Step 2, we want to find out the constant. F prime of 0 is 6 times 0 plus a constant, and that has to equal negative 7. That means the constant is negative 7. And that means that f prime of x is 6x minus 7. And then step 3, f of x is the antiderivative of f prime of x dx. So it's the antiderivative of 6x minus 7 dx. Use the power rule, 6x squared over 2 minus 7x plus a constant. 2 into 6 goes 3, so it's 3x squared minus 7x plus a constant. And then step 4, use the initial value. F of 0 is equal to 8. F of 0 is 3 times 0 squared minus 7 times 0 plus a constant. That has to equal 8. That was our initial condition, one of our initial conditions. So that means these two terms are both zeros. That means that the constant is equal to 8. So that means that f of x is 3x squared minus 7x plus 8. And that concludes this presentation.